Hello everyone. Today we are going to graph quadratic function in vertex form, or the other term for vertex form is graphing form. So this is the equation for the vertex form or graphing form of quadratic equation. Y is equal to A. Our A here is the stretch factor. Our A also will determine if the graph would open up, if it's positive, and it's gonna open down if the if the A is negative. And then we have x minus h squared plus k. Our hk variable that we have here is the vertex. I have another video that talks about what is the effect of h and what is the effect of k, what is the effect of a on the graph. I will put the link of that video in the description box below. So I have a trick on how to, we have this example right here. I will give you a trick on how to quickly graph quadratic function in vertex form or graphing form, whatever the value of a is. Now this is the trick that I'm going to put that trick over here so that we can use this trick to do this problem down here. So first we have to determine the vertex, because from the vertex we are going to look for the other dots in order that we can create the graph of the quadratic function. So let's take the vertex first. So our vertex in this problem is defined here. Vertex is hk. So this is negative, that's x minus 5 and minus 1. Please remember that to get the vertex, this h right here was actually positive because it was coming from x. This is minus h. So this was actually x minus positive 5. So originally the h here was a positive 5. Now I'll give you a trick. Fastest way is whatever the sign of this one, just flip it. You switch the sign and that would be for the h. So in this case right here, our vertex is 5 and our k, we keep this, so that would be 5 and negative 1. So switch and keep. So that's the trick right there. So in this case right here, we're now ready to put the dot. That would be the vertex, 5 and negative 1. So that's gonna be 5 right here and negative 1. This is our vertex. Now to get the second dot, we're going to use this trick right here. So trick to determine the second dot and the third dot. So pretty much like this equation is pretty much like the parent graph. Again, there's another video for that, how to draw the parent graph of quadratic function, but we're going to use that in here to get the second dot. So I'm going to write here second dot. So we are now determining the second dot. So first thing that we need to do is to write, by the way, from this vertex here, we are supposed to go to the right. Let's just go to the right because we don't have to go to the left because they're just symmetric. That means they are gonna match up across. So let's just go to the right. So in here I will that would be over or right 1. So I go to the right 1. Now where would the dot sit? So to do that, I will use this equation right here. So that is y is equal to a x squared. Now we are going to plug this one into the x, so that would be y equals, our a for this is invisible, negative 1. So that's the a right there. So I'm gonna write negative 1. Again, the a was up here, that's a negative 1. And then I am going to put this 1 over here. So I'm gonna put that in here. So our equation would come out to be, so I'm gonna put 1 here. That's how I got the 1 right there. So this would mean y is equal to negative 1 times 1 squared is 1. So our y is negative 1. What does this mean? We are supposed to go down 1. So we go over 1 or right 1 from the vertex. So it says from the vertex. So from the vertex, I go right 1, down 1, because this was a negative. So right 1, down 1. So this is the second dot. To get the third dot, so I'm going to show the work here. Third dot. To get the third dot, we do exactly the same thing, but this time around, we go over or right 1. So I'm going to show over or right 1. So that would be y equals ax squared. So, oh, oops, this is going to be over, not anymore 1, but 2. So since we already done with 1, so over or right 2. So this should be 2. So then we go ahead and say y equals, our a here is a negative 1. So I put in the negative 1. And then I put in the 2 here. So that is squared. So I'm going to put the 2 in here. So that's a 2 here. So y is equal to negative 1 times 4. So then this is y is equal to negative 4. What does this mean? We are going to go down 4. That means right or over 2, down 4. So over 2 from the vertex. It's always from the vertex. That's what it says here, from the vertex. So that is right 2. So from the vertex, 1, 2. And then down 4. So 1, 2, 1, 2, 3, 4. So this is where the second dot is going to sit. And then remember, they are symmetric. So if this is our axis of symmetry, so if the axis of symmetry goes through here, so that means we are going to put a dot across. And we're going to put the dot across here. And this is the graph of this function. So this is the graph of this equation right there. Now this time around, we are going to have the next example. What happens if our a is not 1? So let's take, I'm going to take this. We're going to use this in the next slide. So let's take this example right here. So suppose I have these two graphs here. So at this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, and pause it and check your answer. Okay, so I will put the, we have this trick right here. I'm going to put that over here so we can go back to it. So we write the vertex first. So the vertex for this is, so remember, this is x minus, our h here is actually negative 4. And so that's how we got plus. So negative times negative is a positive. So originally, this is a negative 4. And then we keep this, so that would be a negative 3. Again, the trick is switch this. If that's a plus, make it a negative. And then we keep this. So switch and keep. So that is negative 4, negative 3. So the vertex is negative 4, negative 3. So it's going to sit here. Now we are going to determine the second dot. So to find the second dot, we're going to use this trick here. So I put that in there. So the second dot here would be, that would, first we go over to the right one. So that would be over or right 1. So then we go ahead and plug it in. So y equals, our a is 2, and then we square it. So we're using this equation right here over here. So then this one will go to the spot here. That's 1. So again, the a, I got the a from here. This was the a there. I put that there. So y is equal to 2 times 1 squared is just 1. So we go ahead and say y is equal to 2. And what does this mean? We go up 2. So from here, we go over 1 or right 1 from the vertex, right 1, and up 2. So right 1, up 2, 1 and 2. So this is the second dot. To get the third dot, so all we need to do is pretty much do the same thing, but this time around we go to over or right 2. So I will go over or right 2 here. So then we go ahead and write y equals, our a. Again, I'm using this. So our a is 2. So I put 2 there times squared. The one that we put to the x is the step to the right. We're supposed to go 2 steps to the right. So I put 2 here. So this would come out, y is equal to 2 times 2 squared is 4. So y is equal to 8. What does it mean? We go up 8. So from the vertex, I go right 2, up 8. So right 2, 1, 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. And this is where the dot is going to sit. And then, so then I am going to reflect it across. So this would be sitting over here. And this is the graph of this equation. So I'm just gonna draw the graph. Be sure that you put an arrowhead at the end. That would tell us that the graph is gonna go to infinity. Did you get the same shape of the graph like this? Good. Perfect. Now let's move on to the third example. Okay, so we go over the third example, and I'll put the trick over there so we can use it to do this. So first we have the vertex for this is that's gonna be, again, we switch and keep, so that would be a positive 4 and then 7. So that's positive 4 and 7. So positive 4, then we go up to 7. So this is our vertex. And then we are going to determine the second dot. Again, to determine the second dot, we're going to use this. So that is y. Oh, by the way, we go over or right 1. So we're going to the right 1, then so we go 1. So we don't know, do we go up or do we go down? So based on this is a negative, so we're supposed to be going down, but we need to determine how far do we go down. So first we have, that's again over 1, so I will use that equation over here. So that's y equals negative 1/3. Okay, now in this case here, if we put in the 1, I will give you some more trick if we have a fraction, so that we get rid of the decimal, and so we get rid of like just approximating it where it's sit. We are going to go by anything that is divisible by 3. So the numbers are divisible by 3. 1 is not divisible by 3, so we're not going to use this. 3 is divisible by 3. 6 is divisible by 3. So let's just have 3 here. So write 3. Again, we're not using 1. Again, there's a special case for fraction. So if the a is a fraction, the over or the right value that we put will be anything that is divisible by the denominator. So it will be 3 and 6, because again, we want to get rid of getting decimal and just approximating it on the graph. So we use the 3. So what are we going to do here is we plug in the 3 to the x. So that would be, so I put that in here, and remember this is a squared, just like how I did it over here. But this time around, no problem if it's not a fraction, you can go ahead and do 1 and 2. But for fraction, it has to be divisible by whatever is the denominator. So this is a squared. So I will put the 3 here. So then we go ahead and write y equals negative 1 over 3 times 3 squared is 9. So you see, we can come up with a negative 9 over 3. So then y is equal to negative 3. So we don't get a decimal. So that means we go down 3. So that means over or right 3, down 3. If we did 1 here, it's gonna become 1/3, and we're gonna be approximating where it's sit, and it's not gonna be a perfect dot. The position of the dot may not be perfectly placed. So so that's the trick over there. So we are going to go right 3, down 3. 1, 2, 3. 1, 2, 3. So this is where the second dot is gonna sit. And then we're gonna determine the third dot. So the third dot would be over or right. Again, it should be divisible by 3. So I go to 6. So that's 3 and 6. If this was this was negative 1/2, so I'm gonna use 2 and 4. Okay, so I go ahead and write y equals negative 1/3 is the a, so negative 1/3 parentheses, and then this is squared. Then I'm going to put the 6 here. So this is a 6. So this would come out y is equal to negative 1/3 parentheses. 6 times 6 is 36. So that would come out negative 36 over 3. So our y here is negative 12. What does negative 12 tell us? We go down 12 steps. So I go over or right 6 from the vertex, and I go down 12. So 1, 2, 3, 4, 5, 6. Then I go down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the dot. Then I go across, that would be 1, 2, 3, 1, 2, 3. So I go 1, 2, 3, 1, 2, 3. So this is the dot. And then I go across as well. That would be 6 and 12. So 1, 2, 3, 4, 5, 6. And then 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And so this is where the dot is gonna sit. And then I'm going to connect the dots together. Be sure we have an arrowhead at the end. That means it's gonna go to infinity. Did you get the same graph as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!